Okay, so for the first thing we'll look at is we're matching each equation A, B, and C to one of these four graphs. So obviously one of the graphs will not make sense. So we want to remember that the formula is y equals mx plus b, remembering that m is the slope and b is where you begin. All right. Whenever you're looking at a graph, one of the easiest things to look at is where you begin. All right. So in this graph, you begin here. This one you begin here, here, and here. So you should see some commonality. So some people might say, well, doesn't it look like the graph begins here or here? No. Where you begin is, another word is called the y-intercept. It's where you cross the y. That's where x is equal to 0. Okay? So 0 comma what? All right. In this particular graph, you can see that the scale looks like this. So this is counting up by 2, 4, 6, 8. So when you're given a piece of paper, you want to kind of fill in the scale to make things a little easier for you. This is -2, -4, -6, -8, -10. So this one crosses at -10. So the b is equal to -10 in this particular problem. Here it's pretty obvious, b is equal to 4. In this problem, b, you got to look at the scale. So this looks like it's counted by ones. 1, 2, 3, 4, 5. So b is equal to 5, positive 5. And in this one, it goes -1, -2, -3. So -7, b is equal to -7. So what I'm going to do is I'm going to use this information that I have from each individual graph, and I'm going to go up to my equations and do some elimination. So right off the bat, I can see that all of these beginnings are different. None of them are the same. So when I look at the equation, remember b is the second part of the equation where you begin. So I'm looking here at -10, -7, and positive 5. So these are really dead giveaways right there. They only give me 3 equations, so it's really not that hard. Graph 3 must go with this one because of that +5. There's no other +5. Here you can see graph 4 goes with this one because of that -7, all right? And then finally the -10, which is graph 2. All right, there's more to it than this. Like there is an actual slope. So I do want to recognize how to find that. Basically, it's rise over run between 2 points. So what do I mean by that? Basically, I have one point already highlighted. And what I'm going to do is I'm going to find another point. Any other point on the graph. So when I look here at this graph, I'm going to find like an intersection. Notice this is an intersection. I don't want to go right here because it's kind of in the middle. Here would work or here would work, like right at one of those corners. Do you see that? So that's a point that's in like an intersection. I'm going to do the same thing here. So this one looks good here. This one looks good here. That's fine. And then let's say, see, this one's in the middle. This one's no good. This one looks good right here. Okay. All right. So each one, what I'm going to do is find the step. All right, find the step. We know they're linear, so I'm going to find the step. So basically what I'm going to do is I'm going to create a step. And I'll do this for all of them right off the bat, okay? So this one's going to be real small. All right. And each step, I'm going to figure out what's going on. All right, so from here, I'm going from 4, and then I'm going down. So if I start here, okay, I'm going down 2, 4. So this is -4, okay? Do you understand? I went down 4. And in this part, I went over 2. So that's a positive 2. Do you understand what I'm saying? So that's -4, positive 2. That's the step. When I'm creating the slope, it's the rise over the run. In this case, it's the fall over the run. So the fall is -4 and the run is positive 2. And I'm going to reduce this to a normal looking number. So -4 divided by 2 reduces to -2. Not that that's not normal, but I want a whole number. I want it reduced. So -2 is the slope here. Now graph 1 wasn't used, and you can see that there is no -2 in any of the m's. Okay? By the way, when you have an x alone, it's really 1x, and this is -1x. Okay? So now let's just take a look. Let's see what happens over here. So here is -6, then down to -8, and then -10. So that's 2, 4. So that's a -4 over 2, 4. That's positive 4. So that's negative 4 over positive 4. Negative 4 over positive 4 reduces to negative 1. So the equation m equals negative 1, b equals negative 10. The equation here is y equals negative 1x minus 10, which is c, which we already found. Okay, graph 2, c. This one, if I look at the graph, I go up 1, up 2, up 3, so that's 3, and over 1. So up 3, over 1. By the way, the rise is always over the run. Rise over run. So when I rise 3, that goes on the top. When I run 1, and I got to be careful at the scale, I ran 1, it's 3 over 1. That reduces to here. Graph 3 matched up here. That's the slope. Slope m was 3. Okay? And then finally the last one. This is real simple. I'm rising 1 and running 1. Positive. Rising 1, running 1. So m is equal to 1. And that's where you see this positive 1 right here. All right, that's it.